I'm Karina. I'm a rising junior at Castellia School, and for my final project video, I created a solar panel sun tracker, and this is my final video. So the solar panel is right here, and it basically is going to charge a 9-volt battery right here. And there are two main mechanisms to my solar panel that allow the solar panel to harness the maximum amount of energy from the sun, and one has to do with the solar panel on a day-to-day basis, and the other has to do with the changing of the angle of sun rays, of the way the sun rays hit the earth at an angle each season, and how the solar panels can adjust to that. So for my first one, for the day-to-day one, I'm just going to show you an example of how it works. So I'm going to speed it up a bit. So this is just an example of how it actually works. This is obviously sped up a lot, but to explain it, I'm just going to do it manually just because it's easier to explain this way. So the way it works is it'll make one full rotation every 24 hours. So as the sun rises and sets, it's like this is my sun right here. I'm just going to follow the sun throughout the day. And the way it rotates is that this motor is actually powering this lower gear right here, because the gear is on the shaft of the motor. And then when that meshes with the top gear, it makes the shaft spin, since this gear is hanging on the shaft right here. And then that will actually make the whole solar panel spin, since the solar panel is glued down to the shaft. And then this right here is my Arduino, and this is actually used to slow down the motor, because the motor that I'm working with goes 30 revolutions per minute, and I want it to go 1 revolution every 24 hours. So I couldn't exactly use gears just solely to slow that down, because when I calculated the gear ratio, it ended up being like 1 to 43,000. So I knew that I had to find an alternative to slow it down. So with my Arduino, what I'm doing is I'm using PWM, which stands for Pulse Width Modulator, and that basically means that it's not actually making the motor go any slower or faster, but it actually is turning the motor off and on really, really fast to create the illusion that it's actually just going slower when really it's going the same speed. And then when you want to actually slow down the motor, you're actually just increasing the percentage that it's off for versus on in a given rotation. So then that just gives it the illusion that it's moving even slower. So for example, if this is my current speed and then I want to slow it down, I'm just going to increase the percentage that the motor is off for in a given rotation. So let's say I want to make it move half as fast. Then I'm increasing the amount that it's off for, and then that'll make it move a lot slower. So the motor is actually moving the same amount, it's just going on and off, or it's just off more. And then my other main mechanism, so I'm just going to unplug this. My second main mechanism to my solar panel allows the solar panel to adjust to the different seasons, because as you know, in the summer, the sun rays come almost at a complete 180-degree angle. However, from June to December, the sun rays are actually coming at a different angle, and the angle between the sun rays and the earth is actually getting smaller and smaller. So in order for the solar panel to the sun rays to still hit the solar panel at a 90-degree angle, the solar panel will actually need to change angles. So for example, in December, the angle of the solar panel can actually be like this, so that when the solar panels come down more at an angle like this, they'll still be hitting the solar panel perpendicularly. And then the way I just did this was I used magnets. So there are magnets connected to this piece of wood right here, and then this steel rod is magnetic, so then it can just go up and down. And each month you change the angle. So from June to December, it works its way up, because the angle that the solar rays are hitting the earth is getting smaller. So the angle the solar panel has to get bigger, so it can still hit perpendicularly. And then I use hinges here to kind of, so if I detach the rod here actually, just to show you how it works. So these hinges allow it to move up and down. And then this rod is also on a hinge, so that because this is actually moving up and down in an arc shape, so this rod allows it to kind of move in an arc, so it's not stationary. And then I think for me, my biggest challenge was probably just figuring out the motor in the Arduino, because it's actually not part of the project. The project actually involves a clock timer, a wind-up clock timer, which you just wind up, and then it just kind of slowly unwinds, and it's connected to a gear, so then just slowly unwinding and turning the solar panel. But I wanted to motorize it, so I had to figure out exactly how I would do that, where the motor would go, how it would attach to the gears, and then also figuring out how I could slow it down, and then coding a bit, because I've never used Arduino before, so that was a little bit tricky. But I think it turned out really cool, so I'm really proud of that. And then I think next steps later on, as you can see, this rod is really scratched up, and this is after only a couple of days, so I think in the future, if I want to improve on this project, I think I need to find a better way to use a sliding mechanism. Maybe instead of using magnets, I could use something else, or a better material, just so this can go down more smoothly without scratching anything, because you can barely even read the angle measures now. So I think that's definitely something. And then maybe even motorizing it later on, so that way I don't have to adjust it each month to a different angle. I think that would be pretty cool. So then my whole mechanism would be motorized, this and this would be. And then I think overall, I think it was just a really fun project, because I haven't coded at all, so working with Arduino was pretty cool, because I mean, I haven't had much experience with that. And then I think it was also really cool getting to work with motors and gears, because I don't have much experience with that either. So I think it was just a really cool project overall.